Good afternoon, everyone. It's such an honor to be here among the brilliant minds. And this talk is the last talk, so before you go home, I would like to take everyone to the journey, a journey of how I bypassed the AMSI. And can you believe or can you imagine how much I have suffered during the engagements because of the AMSI? Well, my name is Sherchan, and I'm a security researcher at Cyber Warfare Lab. And I specialize in reverse engineering, malware analysis and development, Windows internals, rootkit writings, and much more. And if you really find me interesting after this webinar, you can find me in the LinkedIn with the same name and same profile. Okay, so without further ado, I would like to take every one of you to the journey. Okay, so it all started when Nick Powers dropped the blog on the click once. To be honest, we are not going to talk about the click once here, but you need to understand what we are actually trying to achieve here. We were actually backdooring the .NET application and trying to deploy that backdoor application to the target application through the click once technology. And we actually gave it a try. It worked well. It worked really fine. But the problem came when our payload was not connecting to the C2. And to load the payload, we were actually using one of the function or one of the technique called Assembly.Load. We were actually using the Assembly.Load technique to load our .NET binary in the memory. But our payload didn't get connected to the C2. And when something goes wrong, I will like to go to the debugger and look from the debugging view without any second thought. Then I went to the debugger, I dropped that backdoor application into the debugger, and then I tried to load the payload with the assembly.load function. Then I saw that it was giving me some exception. It was throwing some exception, and the message was quite misleading. It was saying bad image format exception. And that got me into hold. That got me into scratching my head for 15 minutes because I was just fixing the image format. I was recompiling the binary. I was replacing the binary. But still, I was receiving the same exception saying bad image format exception. But later, after debugging quite a while, I realized that the problem was something else. The problem was not with the bad image format, but the problem was with the AMSI. And here we go again with a classic Tom and Jerry game again. Okay, so let's think how this bypass that I'm going to present you is the unique. To understand the uniqueness of the bypass, first of all, we need to understand what are the common bypasses that are available in the market. And thanks to Pariksha and Yasvi, who actually enlightened on the AMSI and made my life easier in these days. And they have already enlightened on the AMSI and the bypasses. So I'm going to go in a very brief on the common bypasses that we have here. One bypass that we have is the obfuscation and encryption. Here we mangle with the strings. We try to encrypt and encode the payload so that we can evade the AMSI detections or the signature detection. And for me, this was not suitable because the payload actually at the time that I was trying to load was quite huge. It was 1 MB. It was more than that. So the second option that I can go and work around with is bypassing the AMSI by patching in the memory, where we actually target the AMSI-related function and make that function return something that means that, okay, the malware, the payload or something that I'm trying to load is not malicious. So that's what I was happy with. I was trying to go with that one. But the problem with this technique is we have to change the memory protection. Because we cannot simply go and pass the AMSI-related function there. We have to change the memory protection, and that is going to give you another problem. And that is going to create another suspicious event as well. And that's when I actually try to see and try to find something so that I can bypass the AMSI here. And here comes the 1 byte pass. Before we understand what is 1 byte pass, first we need to understand how the assembly.load function is taking our payload from the assembly.load function to the AMSI-related component. And then without wasting any time, I actually put my the implant into the debugger again because we are working with the managed code, and dnspy is a great tool to debug the managed application. Then I went to the function, I went inside the assembly.load function, and there I saw that it's calling runtime assembly and load function. Then I double-click on the function, then I get to know that there is a dead end. The function is actually not implemented there, it's implemented somewhere else. Now, I need to know how my payload was feeding to the AMSI. That's why I try to figure out where the actual function is implemented. Probably you may already know where it is actually implemented. But to who does not know where the actual implementation will happen, let's follow the process. Then I open up the backdoor into the native debugger. And it's really bad to debug the managed code with the native debugger. I'm actually really bad at it. So to help us out to debug the managed application in the native debugger, we have the source debugging extension, which knows a little bit about the CLR implementation, and that's going to help us to dump out some of the information while debugging. Then once the source debugging extension is loaded, we will go and find our function, that is assembly.load function, with the help of the command name to EE. Then it will list out a bunch of assembly.load function there, but we have to select the particular one that we are working with, and that is the one with a byte parameter there. Then we will take the GTED address and disassemble that again. Then we can put the breakpoint and step into the function. So that's actually what you normally do when debugging something. But it is not the case here. Even if we put a breakpoint here in the call, you can see it's calling to the unload image inside the disassemble function. If we put a breakpoint there and try to step into, it's not going to work. That's why we are taking something that is there. It's called metadata token. We are taking the address of the metadata token. Then we are dumping the metadata token to get the method description address. Then once we get the method description address, we are going to dump the method description with the help of the command dump md. Then method description is going to dump the method table there, the address to the method table. We will take out the address of the method table, and with the help of the another command dump empty, we are going to dump the methods that are related to that particular table. But make sure that you use -md flag there, and it is going to list out all the functions that are related to that particular method table. Then we will look for the function that we are looking for, that is the unload image. And there you can see the rectangle highlighted, the last part. In the front, there is address, and that's the address we require. Then we will put a breakpoint on that. Then again, you will definitely going to hit the breakpoint once you trigger the function assembly.load, but it's not going to take you to the actual implementation because the implementation is happening in something else, somewhere else. And that's when you do a little bit of the step into after reaching the breakpoint, and right after the pre-stop worker, just make sure when you get past the pre-stop worker, you check the EAX register, and that's where the actual implementation is there. And the implementation is in the clr.dll with the assembly native load image, and that's the function actually it's going to go when you call the assembly.load function, and it's actually implemented in the clr.dll. Now we know that this load image is implemented in the clr.dll. Now it's time to go and reverse the clr.dll binary, right? Yeah, we can do that. However, the problem is clr.dll is quite huge, and it will take months to understand the DLL. But luckily, I found, well, I was just looking around, I found the function AmsiScan there in the clr.dll. And I was so excited, I put the breakpoint on this AmsiScan function, and then I just hit the G button. And it's going to continue the execution. And interestingly, I found that AmsiScan function was triggered. And you can see in the stack trace how beautifully the payload is going from the load image to the AmsiScan function. Okay, so to understand the bypass, now we are in the very last stage of understanding the bypass, and that's in the AMSI function itself. So how is this AMSI function implemented? If you check into the function, inside the function, there is the first if block. And in the first if block, you can see there are two variables. And one is the G AMSI context, and another is byte and something number, but I'm gonna spell this as a byte variable for the convenience. You can see the first if block is only going to be taken if both of them are null. And once the first if block is taken, it's going to initialize the AMSI initialize function, and then it's going to initialize the AMSI context, and that is going to be set to the G AMSI context variable there. And again, if you notice that there is another function being resolved, that is AmsiScan buffer function. And all the initialization will happen in this first block, and while leaving this if block, it is setting the byte variable to 1, which means that, okay, I'm done with this initialization and everything. Then right after that, there is another if block. This is the second if block, where it is going to check whether the G AMSI context is initialized or not. If G AMSI context is initialized, and in the normal case, it will definitely get initialized in the first if block, and then the actual scan will happen. And if you look at the V18 variable, that's our actual payload getting passed to the AmsiScan buffer, and that's how it was giving us the message there. But where is the bypass? To understand the bypass, first I will explain you something. No matter how many times you execute your .NET application, these two variables, G AMSI context and byte variables, will going to remain null throughout the entire life cycle of the process. So the bypass is how about we writing to one of the variable before we trigger the AmsiScan function. And at this point, I hope you understand what I'm trying to say, but let's go and see here. So the challenge here in this topic is to write only one byte to bypass the AMSI. So where do we going to write that byte, right? And by understanding the AMSI function, AmsiScan function, many of you already know where we are going to write that byte. So we have two locations to write. One is G AMSI context, another is the byte variable. We have a two writable location where we can write, and one good part of this is we do not have to change any memory protection. These both of the variables are already in the writable region. So we can simply figure out the address and we can write into it. Okay, so what are we going to write? And here I forgot to mention that after a couple of investigation, we figure out that byte variable is the preferable location to write. And we'll talk this why. So what are we writing? We are writing anything except the value 0, any positive value. Now take a look at the if logic again. So this is the same function. Just imagine we write the byte variable with the value 1. And now we are going to call the function Assembly.Load again. And by this time, we have already tampered with the byte variable. So next time when you call the Assembly.Load function, it's going to go into this if block again, the first if block, and it's going to check, hey, G AMSI context, are you null or not? Yeah, definitely we have not tampered with the G AMSI context, so it will be null. But we have tampered with the byte variable. And that's what makes the condition false, and the initialization of the AMSI related, any of the AMSI related function will never happen in this if block. And this will completely skip the first if block, which will never initialize the AmsiScan buffer, and gAMSI context will never get initialized. And let me go back to the few slides again. And let's go to the second condition here. So we completely skip the first if block. Now, by default, the gAMSI context is null. As I mentioned earlier, no matter how many times you run the process, the AMSI context is going to only initialize when the first if block is going to meet. But we completely skip the first if block, which means the gAMSI context is null here. That means the first if block will completely skip, and then when we are working with the second if block will completely skip again, because the gAMSI context is null, and if something is null in this condition, it will never enter into the block. That means AMSI will never get to know the taste of our payload here. Okay, time for the little implementation. So we know that we have to write one byte. So first of all, we have to actually know the location of where that particular variable is. So to do that, we are going with the pattern scanning. And then once we identify the pattern in the memory, we are going to take out the address from there. Then we will be writing one byte. After writing one byte in that location, we are again going to execute our payload with the Assembly.Load function. Okay, if you just look at this, I hope you will see it. So if you just look at this vertical rectangle, there is the static bytes which we are going to scan actually, and this will remain intact throughout the version of the DLL. So until and unless you are going to compile that binary again, there's a chance that it's going to remain static all over the entire life of that particular version. And this is the same byte in the IDA, and this is the same byte that we are targeting, and that is in the x64 debugger. And you can see the horizontal bar, that is the actual address that we want to retrieve. And that's where we are actually trying to write that one byte. So this is the little implementation there. You can see we are loading the clr.dll. The address of the, we are just trying to get the address of the clr.dll because that's where we're actually patching. Then if you look at the blue highlighted, those are the volatile, location of the volatile bytes, which we are going to completely take off. We don't care about that. But the one that are not highlighted are the patterns that we are actually trying to scan. And in the for loop, we are actually scanning the pattern in the memory. And then once we find the pattern, we are checking whether it matches the length of the pattern. If it matches the length of the pattern, then we are just going to add the offset 15 there. And that's the actually location of the address that we are actually trying to override. And we will just write a value there just to make sure the whole if block is going to be skipped after that. Okay, so this is the little download and execute Cradle implementation where we are actually writing in the global memory first, and right after that we are actually downloading the payload and loading it through the Assembly.Load function. So here is a little demo. Okay, before I start the demo, here is a two binary that we have compiled. One is with the patch and another is without patch. So first one that is going to be executed here is without the patch, and second time we will be executing with the patch. Okay, here we are actually getting the bad image format exception, and that one is without patch. And you can see actually the backdoor is downloading the payload, but payload didn't get executed that time. And you can see this time we managed to load the Rubius without any problem. Okay, so what is the impact of this technique? Well, right now I can say that without any issue, I can load the tools like Rubius and all the .NET payloads. And no AMSI will be troubling me from doing that. And also, most of the security products, they rely on the AMSI logs and details. So maybe we will able to outside that security tools as well. So what are the takeaways that we are going to get from here? So for the offensive researchers, sometimes just focusing on the target, we can look outside the box and then try to figure out something else as well. And this strategy is the targeted strategy. That means I will give you an example in this. We just saw that I was actually managed to load the Rubius without any issue. I can do that in the PowerShell as well. But the problem is I can load the Rubius, I can load this .NET binary, I can do whatever I want to do with the Assembly.Load function. But at the same time, if I try to run the scripts or the dynamic script, then it's going to be detected. So only the technique that involves Assembly.Load is infected right now. And apart from that, the AMSI will be still in a play. Okay, so for the defenders, despite the payload loading is really stealthier, it will definitely going to leave some post-execution traces. It does not mean that that I managed to load the let's say if the threat actor is managed to load their payload, doesn't mean that they are just going to be happy and do nothing because they managed to load the payload without any issue. So they have to do a privilege escalation, they have to do a lateral movement, they have to do credential dumping and many things, and definitely look for those traces, and that will be lurking around the logs. So having said this, I would like to end my session here. Thank you, everyone.